Off to deliver these logs to the concentration yard that I collected over the winter time. Hopefully they pay for the bulk of the steel I need for my rock guards. I know the size of the steel pile will be much smaller than the size of the log pile. Stay tuned. So I traded a trailer full of logs for a trailer with a couple of pieces of steel. Quite a difference in the volume anyhow, but it was about equal money. I've not got the scale slip back yet. I won't get that for a couple days and the check in the mail, but it should pretty much be a wash. You know, it might be a difference of under $100 perhaps. Anyhow, so I can start cutting and piecing together these things for the rock guards. Now, as far as the design of these rock guards, that's basically what they're going to look like. The track will go underneath these rounds, and the rounds will go on either side of the bearing, which is not really shown in this drawing. So what I'm going to be cutting, the first is the length, how long to make this angle. That's the primary piece of this, and because there'll be a wear bar, which is that flat 2.5 inch wide by 1/2 inch thick flat. I'm just going to weld it on here to give a lot of room for wear and some strength down here where it's sort of unsupported. The rounds are going to be used to connect the two. I'm going to be welded on the inside of the tracks and bolted on the outside, probably 3/4 inch bolt. The other use of the rounds is going to be a standoff, and I'll go over this here in a bit, but I need a standoff because the frame of the track has this lip where this bottom piece is actually welded on the vertical piece. So another look at it here, the standoff. The standoff I'm going to have threaded. There's a bunch of them, so I'm going to send them to a machine shop. They'll drill and thread them. I'll weld them on, and that's what will attach the outside and the inside of these frames, of these rock guards, onto the frame. So the first big decision I need to make is how long to make it. Now I have a 20-foot, all those are 20-foot sections of steel, so the 5x3 angle, which is the sort of the meat of this thing. I'm going to start here, so it'll attach up here, but as far as the rounds go, it'll be cantilevered out a little bit, so I'll have the first one there. But I think I can start it here, provide as much support as I can before it goes through that guard or whatever it's called. So the rounds are going to go here. I'm thinking I may do a round there and a round there, so 2 rounds between each of the idlers. Here is that lip that I was talking about, so the standoff is going to basically be welded onto here and provide a flush mount for this on the side where my flat is going to be. As far as the flat, where the angle is going to be mounted, it's going to be mounted up here, but it's going to be flush with the inside of this. So I'm going to have to cut out for each one of these. So a better idea of what the finished product will look like, or would look like, on a purchased one. I did get a quote for rock guards that would be custom made for this, 6,700 smackaroos, which is why I decided to spend the $500 on steel and some of my time to make my own. But at least it'll give you an idea what they look like, what you get for $6,700 plus shipping. I'll show you that right now. So this is what purchased rock guards would look like. They're a bit longer than the ones that I've designed. They'll go an extra, they'll wrap around the last idler roll, where mine sort of cantilever out and end right there. They have another section there, and I'm not sure if this is the front or the back, but they have a section here, and it looks like they attach to another portion of the frame that I am not going to. You can see here they used a tube or piping with a bolt through it to connect the 2 sides together. Mine will be a solid 1.25 inch round, welded on one side and a bolt through on the other. The other difference is how it mounts. It doesn't appear to be clear here, but I think these actually bolt up into the frame, so the bolt would go upward. and fasten from the underside of the frame. Mine are going to fasten from the side of the frame going in this way. So you'll notice I had some left over. I decided to go with 55 inches long each instead of 60 to make it flush with the frame on the end. 3/8 of an inch thick wall, 3 inches by 5 inches. I think it weighs about 9.5 pounds per foot, so a 20-foot length is just under 200 pounds. So I'm going to stop it here. I put it here just for some illustration. I have a piece leaning up over there because these are going to be a lot closer together because I need to cut around the bearing mount for this idler. So my plan, I'll look at the drawings because the next thing I need to cut is the, well, I can cut the flat, same length as this, and then the rounds will, underneath here, will go between the two and sort of hold them together. But that's the basic plan. They will be, you can see here, about 3/4 of an inch space between the grousers and this guard. So I expect these grousers will hit this quite often. We'll see how bad that is as far as wear goes, and if it cuts a big groove in here, I may have to do something different, but I'll give it a try. So these are 2.5 by 1/2 inch thick. These are 3 inches longer than the angles, so that on each side I'll have 1.5 inches. The pins, the rails, the track links will go in on this side. I'm going to use that 1/2 inch to bend this out, so if you have a link that's here, it's not going to hit the end and jam something and break something. It should hit the edge of this and then slide in. So I'll heat this up and bend it. See here, these will basically be just like that. A little bit of an overhang on each end. I'll have enough of a little lip here to provide a nice weld surface for a fillet, and then weld on the back side here. So to follow up on the logs that I sold and the cost of the steel, this is what a scale slip looks like. It's going to vary by yard. Sometimes softwood is also sold by the ton. This is each log is scaled. At this particular yard, they do separate spruce and fir, and I had a total of 1,100 board feet. I was aiming for at least 1,000, so I hit that. 29 logs. And the current price is $400 per thousand. So that gave me $440 for that load of logs. So it did not quite pay for the steel, but almost. These 3 items, I had one 5x3 angle, 2 flats, 2.5 inches wide, and that round piece for a total of $540. So not quite, but made a big dent in the cost of the steel. So that I don't need to kiss the ground when I work on this thing, I'm gonna elevate it by 4 inches. There's 2x6s I like to put underneath the center of the tracks, one on each side, obviously. So that's where I'm going to align that piece of angle iron. Be flush with this end here. So now I need to mark out where I need to avoid the mount, which is just the bearing mount. Give myself a little bit of play. So I have marked out the areas that I need to cut out, which are a little bit on the top and a little bit on the side, so that this is where the bearings, the fasteners for the idler rollers go. And I want to make round corners. I like to avoid sharp corners, plus I get to use my new mag base drill. It's horrible when I have a project that forces me to buy another tool. So I have a 13/16, nothing special about that, it just seemed to be the right size. I did buy a small set of annular cutters, so I will cut all the circles, or all the radius, the corners out, and then all I need to do is connect the dots. Turn on the power and a super magnet. Oh, and the other thing, I didn't point it out, you might have noticed. This trailer makes an excellent outdoor workbench. And I think I have positioned these, they do fit nicely between the rub rail and the trailer bed, so that I'll miss the pockets as well. There are pockets underneath here somewhere, but I know this one I'm going to miss, and I'll miss the C-clamp. One with the magnet. That was actually louder than I thought, so I'm going to put some earmuffs on. So I flipped this over to do these corners. So I used just regular oil for the first time. This one comes with a reservoir, and I did get some water-based, I guess, coolant. Metalworks Master Fluid Solutions. So I'm going to try that. I think that dispenses the liquid in the center of the annular cutter. We'll see. This is rather expensive. I think it was like $40 for that gallon, but maybe I can use so little of it, it'll still make sense. Might make less of a mess, although it wasn't too bad. Let's give this a whirl. Certainly thicker than I thought it would be. I'm just sort of eyeballing the marks to make them tangent to the lines that I drew. Nothing special. Well, I got all the holes drilled that I want, so I have this bright idea that I can use the chop saw to make the cut between these two, and then I don't know what I'll do for there, but let's see if this will work. Almost. Didn't quite, without making a corner there, didn't quite cut it, but darn it, that's an awful lot of material moved pretty quickly and easily. I'll take it. So, it's reduced what I thought was going to be a lot of work with a torch or something. Still rather thick. I'll have to give this some thought, but we'll come back here in a bit. So after some thought, and I did the end one because that's the easier one, but what I think is going to work out well is to use a cutoff wheel and finish up the corners, stuff like that, that doesn't get cut with just my reciprocating saw. So I've got this one all except that side, so I'll show you how I'm doing it. That's not too bad. Clean up the edges. I was thinking I was going to have to torch cut all this, which was not going to be fun, and it was going to make for messy edges. But that's not too bad. I'll finish these up and we'll come back. So here we are, a couple days later. I was able to finish cutting this out, and it looks good, except this roll is different and it's hitting right there, so I'm going to have to bring this one down. I may just notch out the center of it. It's the only one on this side like that. The other ones are different. I replaced a couple of them. Anyhow, so a couple other things. One is I picked up this magnetic sweeper. I already did my sweeping, just because I knew there were a lot of, like right there, some pieces from drilling and from sawing. So the rusty looking stuff is rusted from either the reciprocating saw or from the cutoff saw. But I wanted to get this off the ground. I don't know what it'll do to my favorite dog over there if she was able to step on some and get them caught in their paws, and I don't necessarily want that metal stuff hanging around my driveway either. There was a lot of stuff down there in that gravel, much more than I would have thought. You can see. Let's see if there's anything more. It doesn't do a great job of picking up this, because sometimes that rust actually causes them to stick. And I'm guessing if it's just a tiny piece of metal, it may not have enough of an attraction to the magnet, but it's picking up quite a bit. Because I know I would lose track otherwise, I have this marked forward, basically towards the blade is forward, and the inner on the right hand side. Because this one is right on the outer side and forward, so the forward's pointing in the same direction and the outer and inner are oriented right. So let's go back to drilling holes. So since I did that one, I've learned a little bit. One is the coolant that I was using is a concentrate, which explains why it was so thick and so expensive. So I mixed up some and marked it machine lubricant. I mixed it about 15% or so. It says anywhere from 10 to 20% dilution or concentration, depending on the nature of the machinery. So it was just easy enough to shoot for midway. It's water-based, so that lubricant is normally used for like a machine lathe or a milling machine where it's constantly being pumped and lubricated, but here it's going to be just drip out and onto the ground. The other thing is I was trying to get this thing to work, and I think I did that last time when we were together, and it wouldn't come out. But so two things I've learned with this thing, which comes with these bits. It is a plunger, and it actually has a valve in there, so this will only drip, only allow lubricant in when you're actually pressing on the metal. When that thing is depressing the valve in here. The other thing is this, when you bring it back up again, it'll push out the core, which I was using needle nose pliers to sort of pull out. So I think that'll make this a lot easier now that I thought I read the directions enough, but probably not in enough detail. So with these things in mind, let's give it a shot. So I know that real thick chalk line is the outer edge where I want to shoot for. Magnet on. Look at that. Took the plug out. So yeah, that worked a lot better. And this is funny because the chips were breaking off with just the oil, and I know one of the functions of lubricant is to help with chip removal. So having the constant lubricant maybe instead of the periodic squirt of the oil gun. Well, that works well. The only downside is now I've lost my marks. So that went quite a bit better than the first one. I really like that lubricating system. Coolant system, I guess, whatever it is. So now let's use this guy. A little bit of grass, never hurt anyone, I guess. Go over it again. It doesn't look like there's anything there, and I still get quite a bit. It does not pick up everything, at least the first time, because these little curlicues can get stuck in the gravel and the grass. On a cement floor, I'm sure it works perfect. And it works darn good out here. So I've got both sides of these cut out for obviously one side of the excavator. So these are the wear strips, 1/2 inch thick, that I'm going to weld here. And 1.25 inch solid rounds. These I'm going to drill a hole here, push this through, and weld it on the other side. And then this side will be drilled and tapped for a 3/4 inch bolt, and that will bolt here, so that obviously I can sort of take them apart, separate them if I need to remove them. On the ends here, I left this a bit longer. I think it's 1.5 inches longer on each side. I'm going to heat it up on here and bend it over, so if the rail happens to come this way, we don't catch the pin on the end of this. It'll hopefully just slide in like it's supposed to between the rails. So the next thing I think I will do is weld these on. The only other thing that I'll have to do then is another piece of this is going to be up here. If you buy them, if you purchase them, the ones I've seen, they bolt underneath. I've decided not to do that, because in order to do that, I would have to take the track off, lift this frame way up so I can put my mag drill underneath there and drill upside down. And then I just have, I think this is 3/8 plate to tap into. But I'm going to bring that up to the side here, and I'm going to weld a nut, which is actually 5/8 of an inch deep. So it'll give me a bit more thread, and it'll make drilling these, I won't have to drill anything. I just have to weld the nut on. I'm not going to, the bolt will not go through the nut, so I don't need to drill these at all. So the installation will be a lot easier. It'll be equally rugged, if not more so, than bolting them from underneath. I don't have to worry about the bolts shearing off. Really, any force on the bolts will be in tension. So to weld these on, what I've done is allowed a 1/4 inch relief. Not sure how well you can see that. Between the edge of the angle iron and the edge here. So that'll give me a nice corner to put a fillet weld in, and then I'll fillet weld here. So I'm going to tack it on with my MIG, make sure it fits, and then I'll weld it home with the stick, the 7018. Well, it's quite a bit heavier. As you can see, I needed the extra weight there on my lever to hold this thing in place. So what I was looking for, one is this, because this is added on cents. This piece here, the wear strip, I'm going to bend out, and I'm going to cut this up at an angle. So if I'm, well, going forward, then there's a chance that this lip here could catch on that. So I want to put this up in good shape. Bend it out, so if a pin comes by right there, it doesn't hit on this either. I'll bend it out, probably so it at least matches the welded on factory idler guard, which is obviously worn quite a bit there. The other thing I was looking at is this clearance here between the grouser and the wear strip, and there's about 5/16 of an inch, maybe 3/8. It's not a ½ inch because I can't fit 2 pieces of 1/4 inch steel, but I can easily fit one with a bit of a gap. I'm guessing that's going to be okay. I'm sure there's going to be some rub on here. This will all be welded. I guess my concern would be, you know, to what extent is it going to really wear through the grousers if there's a lot of contact on them, you know, when the grousers tilt because of the uneven ground. So I finished this up, but I noticed a good welder can tell exactly what rod he's using, probably, by the sound and by the look of the weld. Me, on the other hand, I thought all this time I was welding with 718, and I was welding, I said, boy, this doesn't sound right. It sounds like the voltage is too high. It doesn't look right. The slag is a bit porous, which is not normal for 7018. I welded the whole thing and then realized, oh, I was pulling from my box of 6011 instead of 7018. So that's what qualifies me as not in the category of a good welder. It's not a big deal as far as strength. You can see here it did undercut it a little bit, so the voltage is too high for 6011, which runs on a lower voltage than 7018 of the same rod size. You can see there it's undercut the base metal a little. So after I realized that, I said, well, let me let me weld with the rod I should have used, and there's a huge difference in the look of the weld, the sound of it. It sounded like it should have. I was thinking, well, maybe it's windy, it's impacting the flux. Maybe the flux got too damp, which is a big deal with 7018. In fact, you're supposed to keep those rods in like a lightly heated oven, like, you know, 100 degrees or 80 degrees or something, which I don't have. But you can see the 7018 is a lot nicer, a lot smoother. Seems to build up faster. But the advantage of 6011 here is that it penetrates deeper, particularly on this edge here, which is going to be the wear surface as the grousers will ride on this occasionally as they you know, get cockeyed on uneven ground. So I don't think that's a bad thing at all here. In fact, maybe it's even a good thing. The 7018 is a little bit stronger, 70,000 psi. Instead of 60,000 psi, which is the 60, which that's what the 60 means on 6011. But in both cases, they're much stronger than the base metal, which is about 36,000 psi. It's either 1020, which is the ASTM designation of the steel. I think it's ASTM, or A36, and the 36 again refers to 36,000 psi. So even the 6011 rod is much stronger than the base metal, so I'm not worried about the strength. So now, with that lesson learned, hopefully, the next thing is to take this little edge and bend it up and cut this off so there's no chance of either the pin or the grouser edge catching on this as it rides by. You can really tell the difference grinding, how easy the base metal cut compared to the weld itself and what they call the weld affected zone, which sort of heats up the base metal. It probably hardens it a bit because it gets so hot, cools down rapidly. So I think that'll work. I'll do the same to the other side. I'll mount it on there and see if it still looks okay. Well, there it sits. I'm happy with how it looks. I think these came out good. Plenty of clearance there, so this won't catch. And I have probably a ½ inch of clearance, I don't know if you can see that well, between the end of the pins and here, which is what I'm looking for. And here I have probably 3/8 of an inch. That is missing, but it is very close with the other ones because of the design of the rollers. Have plenty of clearance. So the next thing here, and I just discovered that these work really well for holding this up instead of my cantilever 2x4. Be nice to have these a little bit heavier duty. These are fairly light duty bar clamps, but they work. So the next thing is I'm gonna attach these to the frame on the sides here. So I have, I'm going to use the same 2.5 by ½ inch plate, but I'm not going to put it the entire length. I don't think that's necessary. It would make it really heavy. So I need to figure out where to put them. Probably I'll just put them here, mount them between the rollers. I mean, there's no interference here with these bolts anyhow, But for the time being, I think I will weld on the wear plate for the inner side and put that on before I move forward. So I've got the other two pair, the other pair for the other side welded up. Here to bend this wear strip, decided to make it a little easier on myself. I've ground about halfway through, so I only have to bend 3/16 instead of 3/8. Should be easier to heat, easier to bend, and I'm going to weld this anyhow. I should have done this the last time because that took a lot of heat, wasted a lot of gas to bend that 3/8 of an inch. So this should work out quite a bit better. So both sets are all welded up. You can see under here where that bend was, where I notched out half the thickness of the 3/8. There's a little bit of a hole there where I didn't penetrate. Not that I was intending to. Any force is going to be that way anyhow. It's really not going to go anywhere. I'm not too concerned about it. But if for some reason I did want full penetration, I would have had to have made the V-groove out wider to actually fit the weld in there. So I basically did it as deep as I could with the narrow groove that I made. So we'll wrap this video up for now. The second part of this will be finishing this. So two things basically I need to do is mount these. They have a threaded hole on one end. So they're going to go about here so that the track rail will go underneath. Probably just a little bit above that wear plate. I'm going to drill a hole there, stick this through, weld it on the other side, drill a hole here, and that'll be where a bolt will go through so that I can separate these to take them off. I've heard of some people maybe sort of welding them to the frame and welding them together. I'm afraid to do that because I probably will have to take them off as soon as I put them on. The other thing is I need to put mounting bolts. So here this one's clamped up here obviously, so I'm going to have the same 2.5 by 3/8 flat. I'm going to weld 5-inch sections here wherever I'm going to weld it, or wherever I'm going to fasten it to the track frame. So I'm going to weld these nuts to the frame. There'll be 4 per side on the outer, 4 per side on the inner. So there'll be 8 bolts holding each of these rock guard sets on. So that'll be for the next time. For this time, I appreciate you watching. Thank you very much.